Hello all, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the subject Mathematics 2. Same chapter, series solution of ordinary differential equation, but today's topic is generating function for Legendre polynomials. So what is generating function and what is the use of generating function? Let's have a look on this. The generating function for Legendre polynomial is given by this formula 1 minus 2xt plus t square whole raised to minus 1 by 2 is equal to summation n is equal to 0 to infinity pn of x t raised to n. This is our generating function for Legendre polynomial that you have to remember, okay, because this will help you to solve many examples. Okay, so let's start with the examples. So that pn of 1 is equal to 1. Okay, so we'll start with the our known formula generating function. So we have this is generating function. Now we want to find pn of 1. That means we'll put x is equal to 1 in this both this side. So put x is equal to 1. So we have left hand side become 1 minus this x become 1. So 2t plus t square raised to minus 1 by 2. And in the right hand side this x become 1. Rest are the as it is. So we have this. Now you know that this 1 minus 2t plus t square is 1 minus t whole square. So 1 minus t whole square raised to minus 1 by 2 as it is, and right hand side as it is. Now we can cancel out this 2 because power raised to power, multiplication of power. So we have this minus 1. So 1 minus t raised to minus 1 and right hand side as it is. Now we know the binomial expansion of 1 minus t whole raised to minus 1. So this is the binomial expansion. Now we will equate the coefficient of t raised to n. So on the left hand side we have coefficient of t raised to n is 1, and on the right hand side coefficient of t raised to n is pn of 1, which is our answer. Simple. Okay, so by equating the coefficient of t raised to n both the side, we have the final answer for all n. That means if in MCQ it is asked that what is the value of p2 of 1 is also 1, what is the value of p100 of 1 is also 1. For all n it's always 1. Okay, pn of 1 is 1 for all n. That you have to remember. This can help you in MCQ. Now we have second example. So that pn of minus x is equal to minus 1 raised to n pn of x. So again we will start with the formula of Legendre polynomial, generating function. So we have this is the formula of generating function for the Legendre polynomial. Now we will put x is equal to minus x instead of this 2. Okay, so we have replace x by minus x in equation number 1. So left hand side here this x become minus x, and here if we put minus x, so this minus become plus. So this is our equation number 2. Now same to same we will put t by minus t in equation number 1. T by minus t equation number 1. So this as it is, and this t becomes minus t raised to n, and here if you put this t minus t, so this become plus, and minus t raised to 2, that means plus. So we have this. Now you can see in equation number 2 right hand sides are equal, so we can equate the left hand side this and this. So from equation number 2 and 3 we have this right left hand side of this equation number 2 and 3. Now here uh, we can split this as minus 1 raised to n and t raised to n. Okay, so we have this right hand side become this, and now again by equating the coefficient of t raised to n on both the sides, we have this is equal to this, and which is our final answer. Okay, simple. So simple. Just you have to remember generating function for Legendre polynomial. So now one more formula added to your dictionary, that generating function for Legendre polynomials. Okay. Now we have one more example. Pn of minus 1 is equal to minus 1 raised to n. So let's start with the previous formula that we already know, that Pn of minus x is equal to minus 1 raised to n Pn of x. We all know that. Just we have to replace x is equal to 1. So put x is equal to 1 in equation number 1 gives us this Pn of this minus 1 raised to n and Pn of 1. And we know that for all n, Pn of 1 is always 1. So this is our final answer. which we required. Okay, simple. Similar way we have this one more example. So that Pn of 0 is equal to these two answer. When n is odd we have 0, and when n is even then we have this entire answer. So again, let's start with the generating function, and which is given by this. Now we'll put x is equal to 0 because we need Pn of 0. So we'll put x is equal to 0. So this cancel out. So we have left hand side this and right hand side becomes this. Now we will apply binomial for this 1 plus x raised to n formula. 1 plus x raised to n. Okay, we know the formula 1 plus that nc0 and everything, okay, that you have to follow. So by using that binomial expansion, this 1 minus 1 by 2 t square and so on, that n x n minus 1 by 2 factorial x square and so on, that formula we are using here. So by expanding this we have nth term become this, somehow in between term, okay, 2 raised to 2m, because we know that t contain only even power. Okay, t contain only even power. So by comparing the coefficient of t raised to 2m on both sides, so we have this on the right hand side, and t raised to 2m is, we have, as we told that if we put 2m, so 2m 2m, so 2m 0. So by equating the coefficient of 2 t raised to 2m, left hand side this and right hand side becomes this. And we know that by simplifying this, and we know that there is a term containing odd power of t is absent. So p of 2m plus 1 of 0 is always 0. That's why we have the final answer. Okay, so simple. These are the proof of some examples that you have to just remember how we can use generating function, that you have to compulsory because already asked in GTU. So we have to revise all this topic. Okay, and these are the example based, these two are simple example based on generating function. Okay, and based on simple previous examples that you have to solve by yourself. Okay, so thank you for today's lecture, and we have last lecture for Legendre polynomial is recurrence relation for Legendre polynomial. Okay, so we will see you soon with that recurrence relation of Legendre polynomial. So thank you for today's lecture.